In my previous two videos, I implemented the domain and the application layer of the Football League application using the clean architecture. Now it's time to connect the dots and talk to real world, which means we need to learn how to talk to databases, external services, etc. Stick around with me because in this video, we are implementing the infrastructure and the persistence layer of the Football League application. I will show you how to handle the database persistence, implement some external services, and finally, how to set up everything with the dependency injection. Welcome back to the Clean Architecture series on my YouTube channel. Today, we are implementing the infrastructure layer, which is often much simpler than the domain and the application layer we covered in my previous videos. The core responsibility of the infrastructure layer is to handle the interactions with the external services, such as databases, messaging services, email providers, and storage. The infrastructure is the layer where all the magic happens. This is where we implement the concrete implementations of the abstractions or interfaces we define in the application and the core layers. This allows multiple implementations of the same interface, which we can swap at runtime without changing the business logic. For example, if you have an interface file storage service, one implementation of this interface can save files on the local disk, whereas another implementation of the same interface can save files on the cloud. Similarly, you can also have two implementations of the email service interface. One implementation can use the SMTP server to send the emails, whereas another implementation can use the SendGrid API to send emails. As you can see now, the choice of the implementation becomes a deployment or configuration concern, not a design constraint. When implementing the infrastructure layer, I prefer splitting it into two separate projects, infrastructure and the persistence. The infrastructure project contains implementations for external and third-party services, while the persistence project is responsible for database access and database-related implementations. Let's jump into a practical code example to see how the infrastructure layer is implemented in a real application. I have opened the same Football League Manager application we are building from last two videos. So let's just recap what are the abstractions available in the domain and the application layer. I'm opening the domain project, and inside this domain project we have features folder for clubs, matches, players, stadiums, etc. All these features folder have a related iRepository interface which we need to implement in the persistence layer. In the application layer, we have one interface, iSQL connection factory, which we have used in the CQRS query handlers to run the raw SQL queries using the Dapper library. This is another interface we need to implement in the persistence layer. We also need to implement our application DB context in the persistence layer because we are using the entity framework code to run the commands using the CQRS. Finally, we have some external services. For example, we have an iEmail service which we need to implement in the infrastructure layer to send emails. We have an iFile storage service which we need to implement to save files on the disk. So let's see how all these abstractions are implemented in the infrastructure and the persistence layer. I'm opening the persistence project, and here I have the implementation of the iSQL connection factory. As you can see, this class is implementing the iSQL connection factory interface, and I'm also implementing the iDisposable interface to make sure that the connection object is automatically disposed of when it's not in use. We are injecting a database connection string in this class using the primary constructor, and this connection string is saved in a private field. Next, we are implementing a create new connection method, and in this method, I'm simply creating an SQL connection object. I'm opening the connection, and finally, I'm returning the connection object. Next, we have the get connection string method, which is returning the private field in which we have stored the connection string. And finally, we have the implementation of the get open connection. In this method, we are first checking if the connection object is available and whether its state is open or not. If the connection object is not available or not open, we are creating a new SQL connection object, opening the connection, and finally, we are returning the open connection. The implementation of dispose method is very straightforward. If the connection is available and it's in open state, we are closing the connection and we are disposing it. Next, we implemented our League Manager application DB context object. The DB context object acts as a bridge between your application and the database. This class needs to extend or inherit from the DB context object, which is provided by the entity framework code. I'm also injecting a DB context options type parameter in this class using the primary constructor, and I'm passing this object in the constructor of the base class. Inside the DB context class, we are defining the database sets of our domain entities. For example, here I'm defining the DB sets of clubs, players, and stadiums. These entities are coming from the domain layer of the application. I'm also overriding the onModel creating method. This method is available in the entity framework and it is often used to apply the configurations or the model mapping rules. Inside this method, I used apply configurations from assembly method to apply all the configurations from the current assembly. Next, we need to see how the repositories are implemented. I'm opening the club repository class, and this class is implementing the iClub repository interface available in the domain layer. The implementation of this class is very simple. The first method we implemented is the add async method. This method will accept a club entity, and it will add this club entity in the club DB set available in our DB context. Next, we have the commit async method, and in this method, I'm using a save changes async method available in the DB context. This method automatically detects all the changes happen in the DB context and persists them in the database. Finally, we have a method that accepts an ID parameter, and inside this method, we are using the find async method to return the club matching with this ID. As we are using the entity framework code first in this project, so we also need to create a class to define the configurations of our domain entities. For example, here I have a class club entity type configuration, and in this class, I'm defining all the entity framework related configurations for my club entity. This class needs to implement the iEntity type configuration interface available in the entity framework code. And inside this class, we have a configure method where we can define all the configurations. The configurations are very straightforward. In the first line, I'm defining that my club domain entity will map with the clubs table in the database. Next, I'm defining how the ID property of the club will be configured. For example, I mentioned that this property will be a required field, and I'm also using the value generated never method, which tells the entity framework not to automatically generate the value of this property at the time of saving the entity. Next, I'm telling the entity framework that this ID property will be the primary key property of my table, and this property will have a clustered index with a specific name. The next three configurations are almost similar. I'm specifying the maximum length of the name, photo URL, and the website URL property, and I'm also telling the entity framework that these properties are optional. Finally, I have a configuration of the isDeleted property. Similar to the club entity, we can also implement the repositories and the entity type configurations for our other domain entities such as players, stadiums, matches, and leagues. I think now you have an idea how to implement the persistence layer. Let's go to the infrastructure layer and see how we implemented the external services. First, we implemented SMTP email service. This service implements the iEmail service interface available in the application layer. Inside this service, I declared a private SMTP client object and a private from field. Next, inside the constructor of this class, I injected the iConfiguration object, and using this configuration object, I'm reading a specific section from my appsettings.json file. The section name is SMTP, and let me show you how it is defined in my appsettings file. This SMTP section has some properties related to SMTP. For example, the host property will specify the SMTP server host name. The port property will specify the port we will use to send the emails. Similarly, we have the username and the password field to authenticate the user. And finally, we have the from field that will specify from which email address we will be sending the emails. Once we have the reference of this complete section available, we can read all these properties very easily. For example, here I'm initializing my private from field using the from setting available in the app settings. Next, we are creating an object of SMTP client. In this object, I'm setting all the properties by reading the data from the app settings. Once we have our SMTP client object ready, we can now implement the send async method. Inside this method, I created the mail message object, and in this method constructor, I'm passing the from private field and all the other parameters passed in this method. I'm also setting the isBodyHTML property to true. That indicates that the body of the mail message is HTML. Finally, we are using the send mail async method to send the messages. Just like the email service, I also implement the local file storage service, and this service implements the iFile storage interface available in the application layer. I first declare a private root path variable, and this root path field is initialized using a specific setting available in my configuration file. This setting can specify the root path where we need to save the files. I'm also adding a condition that if this setting is not available, then I will specify the current directory of my project as a root path. Next, I'm checking if the folder specified in the root path is available on the disk. And if it is not available on the disk, I'm using a create directory method to create that folder. Next, we have the implementation of the delete async method, and this method can be used to delete the files from the disk. The implementation of this method is very straightforward. I'm first checking whether the file is available on the disk, and if it is available, only then I'm deleting that file. The last method is upload async method. In this method, I'm creating a new file name by appending the new GUID with the file name passed into this method. Next, I'm creating a full path of the file by combining the root path and the unique file name. Next, I created a file stream object and I'm passing the file path as the first parameter. And finally, I'm using the copy to async method to save the file on the disk. Once we have all our implementations ready, we need a clean way to register all these services so that the other layers can use the application interfaces without knowing the infrastructure details. We already created a dependency injection class in all these projects in my previous videos. This is the class where we can register our services one by one. In the infrastructure project, we implemented two services. The first service I need to register is an email service, and this email service is static by nature. So I will register this service using the add_singleton method. We need to specify the email service interface and also need to specify the concrete implementation of that interface available in the current project. Same way, I can also register my file service. Similarly, we can go to the persistence project and register all our services in the dependency injection file available in that project. Before we register our SQL connection factory or DB context, we need to specify the entity framework where the database is located. Normally, we specify this using a connection string. To read the connection string from the abstractions.json file, we can inject the iConfiguration object in this method. And then we can create a local variable connection string and we can read the connection string using the getConnectionString method available in the configuration object. Let's say the name of the connection string in our appsettings.json file is a league manager. The first service I'm going to register is SQL Connection Factory. We already know we need to pass the connection string in the constructor of the SQL connection factory. So I am passing the connection string directly in the constructor of this class from here. Next, we need to register our DB context. And to register the DB context, I can use the addDBContext method available in the entity framework. In this method, we first need to specify our custom DB context object. And we also need to specify that we are using the SQL Server database using the useSQL Server method. This method will also accept the same connection string we passed in the SQL connection factory. Finally, we can register our repositories one by one. In our case, we already have iClub repository, so we can register that repository here. Now we have the solid domain, application, and the infrastructure layers of this project. We are now ready for the final step, and that step is to build the presentation layer of this project. In my next video, I will implement the presentation layer of this project. We will hook it up with our use cases, and finally, we will see everything in action by performing some database operations. Please subscribe to my channel so you don't miss my future videos. Until next time, stay awesome.